My name is Dr. Kamran Zakaria. I am nominated as your Advanced Calculus and Linear Algebra teacher. The course code is MT332. This is the introductory class where you will see the session marks criteria, course outlines, and topics of the course. This course is used as tool to solve different problems of your mechanical engineering field. It may be utilized in solving the problems of your different subjects like fluid dynamics, like control theory, air condition maintenance, power plant maintenance, etc. So world is concerned with the problems, so mathematics is give the way to solve the problems and overcome the difficulties. For example, economical problems, electronic problems, computer science problems. Different example will be studied with the application in this course. Sessional marks criteria is as following. Midterm will be taken in the 11th week and 20 marks is allocated for midterm examination. Complex engineering problem will be assigned to the students in 8th week and 10 marks is allocated for complex engineering problem. Quizzes and assignment will be conducted in 3rd, 5th, 9th and 10th weeks. 10 marks will be allocated for quizzes and assignment. So the sum of these numbers is equivalent to 40 session marks. The course is divided into 4 CLOs. The first CLO of the course is ability to solve system of linear equations and to apply in related field. In that CLO, we will study all type of the solutions, different types, to find out different values for the system of equation. We will check whether the system is consistent or inconsistent. What should be the rank of the matrix? By using rank, whether the system is consistent or inconsistent. In CLO2, we will study how to calculate the eigenvalues and eigenvectors and will apply it in simple engineering problems. It is very useful in order to solve system of differential equations. By using eigenvalues and eigenvectors, we may check whether the system is stable or unstable, oscillatory stable. The third CLO of the course is related with vector spaces. In this CLO, we will study Euclidean space or Hilbert space. It is a popular space, and we will see how may we maintain vectors by using bases and dimensions, and we will see the application of vector spaces in different engineering fields. The fourth CLO is related with multivariable functions and related topics. In that CLO, we will study partial differentiation, extreme value problems, double integrals, triple integrals, line integrals, surface integrals, volume integral, different theorems including Green theorem, Stokes theorem, divergence theorems, and their simple application in different fields. Before telling the course contents of Acla 332 course, I would like to say something about linear algebra section of the course. The definition of the linear algebra is the study of system of equation. So we know there are a lot of system of equations in our engineering fields. For example, connected tanks is one of the example of the system of equation. We may obtain the system of equations and we may find out its solution by the technique of linear algebra. The second definition is it is a branch of mathematics that is concerned with vector spaces and linear mappings between them. Third definition, which is a quite simple definition, a branch of mathematics that is concerned with mathematical structures closed under the operations of addition and scalar multiplication. And that includes the theory of system of linear equations, matrices, determinants, vector spaces, and linear transformations. So you see, this definition says something that says something about the importance of linear algebra. The topics in linear algebra section are following. First topic is linearity and linear dependence of vectors, basis dimension of vector space. So in this topic we may define every vector which belongs to a vector space. For example, we have a vector space R3. So each and every vector of R3 may be defined by using the basis. In order to define the basis, we must find out the linearity and spanning of the vectors. So we will see in detail when we will start the topic. Secondly, we will study the field matrix and the type of matrices. So there are different types of matrices are singular matrix, non-singular matrix, symmetric matrix, non-symmetric matrix, upper lower diagonal matrix, tridiagonal matrices. So these concepts are very useful in order to solve the system of equations. Rank of matrix also will study using row operation and special method. Echelon and reduced echelon forms of a matrix we will study in detail when we start the topic. Determination of the consistency of a system of linear equation using rank. Transition matrices, basic concept of tensor, eigenvalues and eigenvector of a matrix, diagonalization, Cayley-Hamilton theorem, and application of linear algebra in engineering. Secondly, we will study in this section different vector spaces. One of the vector spaces, which is a famous or popular vector space, is called Euclidean space and its transformation. So geometric representation of vector, norm of vector, Euclidean inner product, projections and orthogonal projections, Euclidean n spaces, n properties, Cauchy-Schwarz inequality, Euclidean transformation, apply geometric transformations to plane figure, composition of transformations. So these topics we will study in linear algebra section, and we will study in detail each and every topic with examples. Example number 1, you see in this example you have two tanks. Tank number 1 is A1 and tank number 2 name is A2. So if you want to find the stability of the system of tanks, we may apply the linear algebra technique to find out whether the system is stable or not stable. Or if you want to solve the system of equation, so we may apply the technique of linear algebra in order to find out the solutions of the system of equation. So you see the importance of linear algebra in one of the application. It is a very usual application, very useful application in order to find out the flow, or in control theory you may apply the linear algebra technique. So in this example it is clearly defined the flow of water from one tank to the other tank. Both are the mixing tanks. In first tank, for example, one salt with water is mixed is being mixed, and second tank water and salt too is being mixed, and we are interested in to find the amount of these salts after certain period of time. For example, we want to find the amount of salt in tank 1 after 5 minutes and amount of salt after 2 minutes. So how may we find? We may not predict directly. We may not. We may not apply any other technique, but mathematics or linear algebra technique gives you the accurate answer of the amount of salt after a certain period of time. Why I said it? Because after solving the system of equation, we may find two functions. First function is a1, it is also depending on time, and second function it is a2, it is also depending on time. So by solving these two differential equations simultaneously or by using linear algebra technique, we may obtain two functions a1 and a2. So by putting the very different values of time in these two functions, we may easily find the amount of salt after a certain period of time. Or if you want to find the volume of the tanks after a certain period, so we may easily find out the volume of the tanks after a certain period of time. So this example gives us the importance of linear algebra technique. So you see in this slide, here we have the linear system of equations. First equation is 3x1 plus 4x2 minus 7x3 equals to 5. Second equation is 2x1 minus 3x2 plus 9x3 equal to 7. 7x1 plus 2x2 minus 3x3 equal to 4. So how may we solve this system of equation? In metric, you already know the technique like Cramer rule to solve this system of equation, but that technique is very limited for 3 equations or for 4 equations. But consider 50 equations system of 50 equations system of equation. So how may we apply the Cramer rules there? So it is not applicable. So in order to get the solution easily, so we may apply the linear algebra technique to find out the values of 50 variables or of 50 equations. This is another example of the system of equation. Here you see the example of circuit. First circuit tells us that the rate of change of current with respect to time equals to voltage upon inductance. Second equation tells us that the rate of change of voltage with respect to time, it is equivalent to minus I over C minus V over RC. So it will give us the system of equation. Again we have to apply here the linear algebra technique to find out its solution. So these two examples tells us the importance of the techniques of linear algebra in various fields. In advanced calculus section, we will study the partial derivative and its application in extreme value problems. For example, if you want to find the maximum and minimum values of a given objective equation under various constraints. So we may apply the technique of partial derivatives. So what is partial derivative? Partial derivative is nothing but it is the rate of change with rate of change of dependent variable with respect to dependent variables, and we will see the application of partial derivatives in various fields. Secondly, we will study double integrals, triple integrals, and their applications in various theorems. The theorems are Green theorem, surface theorem, Stokes theorem, and divergence theorems. So these all topics are connected with multivariable calculus. So it is very interesting part, and we will study in, in depth when we will start this section. It is a course outline of second section of advanced calculus. Here you see the different topics regarding advanced calculus. All are related with multivariable functions, multivalues functions. That function depend on more than two variables. So here you see the topics are related with stationary points, maximum or minimum points, and higher order partial derivatives, double integral, triple integral. So you see all the topics are related with multiple variable functions. Second paragraph of course outline is related with vector calculus. In this section, we will study different topics related with multivariable functions like vector differential operator, Laplacian operator, line integrals, surface integrals, volume integrals, and the theorem related with these topics. The theorems are Green theorem, divergence theorem, and Stokes theorem. So these all theorems are very useful in order to calculate flux, work done, energy, etc. So these are very important quantities in engineering field. This is third example. Here we see if you want to find the maximum value of the temperature at any point on the metal plate. So here we have to apply multivariable technique to find out the highest and lowest temperatures on the metal plate. Similarly, next example is the cheapest storage tank example. So here you may apply the multivariable technique or advanced calculus technique in order to find the maximum and minimum volumes of the tank. In line integral topic, basically we convert the domain of x-axis into the domain as curve. So curve, in this figure, curve starting from A to B is become the domain of the integral. On such domain we have to calculate the integral. So that integral will give us the total work done of the particle moving from A to B. So it is very useful to calculate the work done of the particles in different fields. By using Green theorem or by using Stokes theorem, we may calculate work done of the particle. In this diagram, for example, a particle is moving along the dotted lines on the curve C, and on the vertical lines and on the boundaries of the R and on the dotted vertical line towards upward with our semisphere. So by using Stokes theorem, we may calculate the work done easily. So these are the recommended books for the course Advanced Calculus and Linear Algebra MT332. Book number 1 is Elementary Linear Algebra by Howard Anton, 7th edition. Second visible book is Advanced Engineering Mathematics by Erwin Crazy, 7th edition. Calculus, third book is Calculus and Analytical Geometry by Howard Anton, 5th edition. And one more book is Elementary Linear Algebra by Bernard Coleman, 8th edition. So these books are enough for the course MT332 Advanced Calculus and Linear Algebra. Also, my lectures are feasible for study, but if you want to study further, you may study the topics in these books. Now we will start our course from CLO number 1. The heading of CLO number 1 is System of Equations, including the solution methods of system of equations, consistency of the system of equations, rank of the matrices, and so on. So from beginning, if we start from matrix algebra basics, it is just for recalling from your old information about matrices. So what is matrix? Matrix is nothing but it is an array of elements arranged in rows and columns, and it may be denoted by A subscript ij, where I is the row number and j is the column number. So in short notation, matrix may be written as curly brackets aij curly bracket close or square bracket a11 comma a22 up to a1 1n, and second row is a21 up to a2n, similarly am1 up to amn. So here in this matrix, n columns and m rows, and the dimension of that matrix may be written as m rows and n column, and or other word you may see m cross n matrix. It is m cross n matrix. Now we'll study the types of matrices. The basic types of matrices is, one of the matrices is called row vector. So in this type of matrix, the dimension of that matrix is 1 cross n, and in such type of matrices only one row, there exists only one row, and in short notation it may be written as aj, or in long notation it may be written as square bracket a1 a2 comma up to an. Second type of matrix is column matrix. In column matrix or in column vector, we will have only one column, and the dimension of that matrix is m cross 1, and it may be written as, in short notation, is curly brackets ai curly bracket close, or in square bracket it may be written like that a1 a2 up to am, and symbolically it may be written by symbol A or capital, any capital letter. Third type of matrix is square matrix. In a square matrix, the number of rows is equivalent to number of columns, or in other words, number of rows are equals to number of columns. So in this matrix you see how many columns? 3 columns. How many rows? 3 rows. Since both are equal, so you may say that matrix is known as square matrix. Similarly, here next type of matrix is called symmetric matrix. Symmetric matrix is such a matrix if we exchange its rows by columns, matrix is not changed. In short notation, it is written as Aij in curly bracket equals to curly brackets Aji for all ij. For example, in that matrix A12 must be equivalent to A21, A33 equals to A33. So you may say that by definition the original matrix A if equals to transpose of matrix A, so such type of matrix is known as symmetric matrix. Next type of matrix is called diagonal matrix. Diagonal matrix are such a matrix where there exist only diagonal elements. Of diagonal elements are all equivalent to 0. Right? So here is the example. You see D equals to D11, D22, D33. So these all diagonal elements are present and all off diagonal elements are equal to 0. If you multiply, add, subtract the or scalar multiplication of diagonal matrices, so these operations also preserve the diagonal matrices. This is one of the property of diagonal matrices. Next type of matrix is lower triangular matrix. Lower triangular matrix is such a matrix where upper diagonal elements are all equivalent to 0 and lower diagonal elements are non-zero. You see in this example L11 0 0 0 0. Second row is L21, L22 and all other elements are 0. And L31, L32, L33 are present and other elements are equal to 0. So such type of matrix is called lower triangular matrix. So here's the question. Can you solve the first equation? The answer is no, because here we have only one element, that is L11. So you may directly find its value from its right hand side. Next type of matrix is upper triangular matrix. Definition is upper triangular matrix has a value of 0 for all elements below the diagonal, and above or equivalent to the diagonal there are non-zero values. Question is, can we solve the last equation? The answer is no, because we may directly obtain its value. In short notation, it may be written as curly bracket uij curly bracket close equal to 0 for all I is greater than j, where I is raw number and j is scalar number. Here is the exercise for the types of matrices. First example, we have to write a 3 by 3 diagonal matrix. So you know the diagonal matrix is such a matrix where only diagonal elements are present and off diagonal elements are 0. Right? So you have to write such an example here. For example, 300, 050, 006. That is an example of diagonal matrix. Next example is related with upper triangular matrix. So you know the upper triangular matrix is such a matrix where the upper elements of the diagonal are all present and lower diagonal elements are all equivalent to 0. For example, 4 1 1 1 0 1 2 3 0 0 3 1 0 0 0 5. So that is an example of upper triangular matrix. The third example, you have to give 4 by 4 skew symmetric matrix. You know the definition of skew symmetric matrix, that is the matrix A must be equivalent to minus A transpose. So you have to write an example of 4 by 4 skew symmetric matrix here. Next example is related with 3 by 3 upper triangular symmetric matrix. So you know the definition of symmetric matrix. The definition of symmetric matrix is the matrix A must be equivalent to A transpose, right? Similarly, you write here the 3 by 3 lower triangular skew symmetric matrix. So you know the definition of a lower triangular matrix as well as a skew symmetric matrix. What is skew symmetric matrix? It is like that. The matrix A equal to minus A transpose. So you have to write 5 matrices in this exercise. Here you have to write the name of the matrices. The first example, you see, only diagonal elements are present and all diagonal elements are all equivalent to 0. So that is an example of diagonal matrix. In second example, you see all diagonal element and upper diagonal element are present and lower diagonal elements are all equal to 0. So that is an example of upper triangular matrix. So you have to write the name of other two examples here.